Okay, so what we're going to do is look at another important concept called expected value. And basically, what it is, it's an average that we can expect to get from an experiment that has several outcomes that each occur with different probabilities. So here's the setup. We have an outcome that has possible values of x sub 1, x sub 2, all the way up through x sub n. So what we're talking about here is n different outcomes. Okay. And each outcome has a probability associated with it. So the first outcome that we're calling x1 has probability p1, x2 has probability p2, and so on down to xn, which has probability pn. And one thing to take note is that the sum of the probabilities that are used has to equal 1 because we have to encompass the entire experiment. If the sum of our probabilities is only 90%, that means there's a 10% hanging out there somewhere that we didn't think about. So then this idea of expected value, which like I said before is basically an average, it's found by multiplying each probability by its corresponding outcome value. So x1 times p1, p2 times x2, and so on, and they just get added together. It's as simple as that. So let's look at an example of how we would use expected value. So let's say we have a large group of people who were asked the number of times per week they order delivery with restaurants. And in this particular survey, no more than 3 people, nobody said more than 3 times. And so this is the probability distribution of that, if you will. So this means that 20% said no times at all during the week. They cook every day for themselves. Hey, that's wonderful. 60% 1 time, 15% 2 times, 5% 3 times. And realize that the sum of these probabilities is 1.00, which means this is legitimate to do. So the expected value is, well, let's see. We take 0 and multiply it by 0.20, 1 and multiply it by 0.60, 2 and multiply it by 0.15, and 3 multiplied by 0.05. So we know that this is 0 right here, so I'm not even going to bother calculating that. This is 0.6, this is 0.3, this is 0.15, and it looks like the expected value is 1.05. So on average, if I asked a person how many times a week they get delivery from a restaurant, we would expect 1.05 per person. Now, that's kind of a weird number because no one is going to say 1.05. But what this is it's an average per person. So that's kind of the little behind the scenes meaning here. So meaning if I asked 1,000 people, we would expect 105. And the way we get that is by taking 1.05 times 1,000. Okay, so that expected value is just per person. So it makes more sense when you talk about a larger group. How many people would you expect to say they've gotten delivery? You'd expect 105 in 1,000. Okay, so 1.05 was the expected value there. Now let's look at another example, a little bit more applied here. So we have a store that offers a protection plan costing $36 on an appliance that has a replacement cost of $800. The appliance fails 0.4% of the time while still under warranty. What is the expected value of the warranty to the store? So now what we have to do is put ourselves in the store's shoes. Okay, so either the appliance works or it fails. Well, if the appliance works, they get the $36 and they never look back, right? They get the money for the warranty and it never gets used, so they've made that $36. It's great. But if it fails, well, let's see what happens here. They still get the $36 for the warranty, but then they have to replace the appliance for $800. So that's going to be negative $764. So they lose $764. Now, how often does this happen? Well, we know that it fails 0.4% of the time. which in decimal form is 0.004. So there's the probability that goes along with negative 764. And I'm just going to move this 36 over here because I'm going to make a table-looking thing here. How often does that happen? Well, if the appliance fails 0.4% of the time, the appliance is going to work 0.996 of the time, or 99.6% of the time. So the expected value would be, well, here again we are, 0.996 times 36, the probability times the value, plus the probability times the value, and we'll get a little bit of help from our calculator here. It's 0.996 times 36 plus 0.004 times negative 764, and that's 32.8. So that means on average, for every $36 warranty that they sell, they expect to keep $32.80 of it. So again, looking at the big picture here, let's say they sell, I don't know, 1,000 of these appliances. They expect to keep 1,000 times 32.80, which is $32,800. Which seems like a lot of money, but remember, if they sold 1,000 of them, that's $36,000. So they're going to expect to lose a couple along the way. Okay? So I hope that that helps you understand how to compute expected value and why we use it. I'm going to have another video about how do you set the price of the warranty when you want to force a certain expected value. So be sure to check that out. Thanks for watching.